Two down, two to go, halfway there. We got a lot of algebra on this page. Let's see, it's six problems. Let's see how we do here. Now, the first thing on these are slightly different, I guess, from the previous problems because we had a bunch of parallel lines. We said whenever we have parallel lines, we chop the sides up proportionally. All right, now if we look at this problem, no parallel lines, we have a triangle. However, we do have this piece right here. This is not uh, a 90-degree angle, right? We don't know that that's a 90-degree angle. I don't know that these two things are congruent. I can't say that, all right? All I know for certain is that this angle right here is congruent to that top angle, all right? So this segment right here is what we call an angle bisector. Now, fortunately for us, we know that anytime we do have an angle bisector in a triangle, it chops up the sides proportionally. So these problems are going to look just like the last ones, but with triangles as opposed to parallel lines. And there are multiple ways we can set these problems up as well. So if we just, look at them, the sides are chopped up proportionally. If we understand that unit, then we should be good to go. Or I guess that concept. If we understand that concept, we should be okay. So I'm going to say 8 over 24. Well, hey, that is proportional to x over 9. Right? And then we solve it. So yeah, 24x. 24x equals, I have no idea what that is. I could probably figure it out. 18 times 9, it's 162. All right, divide both sides by 24. 162 divided by 24, that gives me 6.75. All right, so that's, option number one. If I wanted to instead, if I saw this one more, or first, if I saw that one first, let's try that one instead. Let's see what we get. 18 over x. That is going to be proportional to, well, we have to go in the same order, so I'm kind of going left to right on this one. So we have 24 ninths. Right? And now we cross multiply. And if you kind of notice, look at the two proportions we have set up. Everything is still on the same diagonals. So we're still going to do 18 times 9. That gives us the 162. We're still going to do 24 times x, which gives us the 24x. We divide it away. We're still going to be left with that 6.75, right? So there's a ton of ways that we could set this up. Really, the only incorrect way we would do is if we drew lines between the two and the lines cross, right? If the lines cross, that is bad. So what I mean by that is, compare all the sides. If I do that, the lines don't cross. We're good. Make a fraction that way. If I compare those two, the lines aren't crossing. That's fine. Make a fraction out of those two. All right. So that's kind of I guess, the shortcut way for identifying which ones to compare. All right. Let's do the same thing here. I have some vertical angles. All right. So we have to be careful on which ones are we going to compare now, because if you look at that left triangle, I give you 3 pieces of information. But if you look at the one on the right side, there's only 2 pieces of information. So we just, have to be careful on how we compare the sides on this guy. It's pretty easy to see. Well, I don't want to say easy. Look at the 6 and look at the 8. Those are between the 2 angles. All right, so that's going to be the easy one to tell that those should be compared. So I can say 6 divided by 8. All right, now what we're doing is, if I were to write a similarity statement, if these triangles had letters, I would have to go counterclockwise on that first triangle, but I would have to go clockwise on the second triangle. All right, so I'm comparing 6 to 8. That means the next stop I would have to make would be x and 24. All right, so those are going to be the ones that I should compare. All right, so I'm going to say 6 over 8 equals x over 24. All right, so that's going to give me, I think, 144. 144, 120. Yeah, 144 equals 8x. All right, divide away the 8, and we're going to have x equals, I don't know what that is, 18. X equals 18. All right, and that one's done. Now, I know I'm not asking for this side, but maybe we wanted to go above and beyond the Call of Duty, right? We're really going for that Falcon Flight Award. I would just compare the other sides as well. So we got 6 over 8 is going to be equal to, we're going to have to go 9 over y. So we have 6y equals 72. So we're going to get y equals 72 divided by 6. That's going to give us a 12. All right. And again, we should be able to, if we were to check all of these, 6 divided by 8, I can divide both of those by a 3. I get 2/3. No, I don't. How about I get 2? I can divide them both by, can't divide them both by a 3. I can divide them both by a 2, and I get 3/4. Okay. Let's see. I got 18 over 24. I can divide both of those by a 6, and hey, I have 3 over 4. And then on the last one, I got a 9 and I have a 12. I can divide both of those by a 3 and I get 3/4. And once again, all of those are the same number. All right, on to the next one. All right, I did one similar to this. So here's what I'm going to do. I'm going to take both of these triangles and I'm going to split them up. All right, so I get the smaller red triangle. If I fill in all the sides here, I get a 5, I got a 7, and I have an X. If I look at the green triangle, I have a 10, I have a Y, and I have an 8. All right. So match up the correct sides here. Let's see here. I got a 5. That matches up with an 8. I have an X. That matches up with a 10. All right. Compare them. 5 over 8. 5 divided by 8 is going to be proportional to X over 10. All right, so I got 50 equals 8x. That won't be a nice number, but that's okay because 50 divided by 8, that's a relatively clean decimal at 6.25. All right, and I'm going to do the same thing for the y values. All right, so 5 and 10, those are kind of the numbers that I have for both. I take it back. I'm going to do, which one is what I want to do now? I'm going to do 5 and 8. 5 and 8, those are the numbers I have for both triangles. I'm going to say 5 divided by 8 is going to be equal to 7 divided by y. 5y equals, I think that's 56, right? And divide that by 6, I think that's going to be 10.2. 11.2. Dang it, that's close. 11.2. Right. But there we have it, right? Just again, set up those proportions, make sure everything is sound. And there we have it. Yeah, that's really all I have to say about that one. On to number 14. All right, this one, a little bit different. I need to come up with an expression for this piece right here. Now, it's very tempting to put a y right there. All right, anytime we see an X and we think, oh, I have a blank spot, I'm just going to throw another letter in there. We could put a y there. But it's going to be a lot easier if we keep it all in terms of a single variable. They're already using an X. So here's kind of the way to think about it. If this piece was like a 10, all right, I don't know what it is. If it's a 10, then this guy has to be a 5. All right, if this is a 7, this would have to be an 8. If this is a 1, this would have to be a 14, right? Both of those numbers have to add up to 15. Or if you want to think about it, whatever this number is, right, whatever that X is, I just subtract it away from 15, and that gives me the remaining side. All right, so this piece, instead of putting a Y there, I'm just going to go ahead and call this guy, I'm going to call this 15 minus X. And that's going to make life a lot easier because now I can compare these two and those two. All right, so I can say 8 divided by 15 minus x. That is going to be proportional to, we got 12 over x. And now we can cross multiply this guy. We're going to get 8x equals 15 times 12. That's 180 minus 12x. Add the 12x over, I got a 20. X equals 180. 2x is 18, so that's going to be x equals 9. This guy. All right, and that one's done. All right, proofs. So let's see here. All right, let's get our statements. Let's get our reasons. All right, I got 8 minutes before the end of the school day. Let's see if I can finish. Step 1, angle 1 is congruent to angle 2. Why do we know that? That's just given. All right, that's given. Now, what do we do from there? Well, I'm going to mark it on the picture. Angle 1 is congruent to angle 2. That's all we have. Now, there's a few different ways that we could go about doing this problem. 1 and 2 are corresponding angles. Those corresponding angles happen to be congruent. Therefore, those two lines are parallel. Since those two lines are parallel, 3 and 4 are also corresponding angles, so those are also congruent. So that's a lot of steps involved. That's going to take us 3 or 4 steps to get there. If we're clever about this one, notice how I got a big triangle and I got a small triangle. All right. Both the big triangle and the small triangle share angle P. All right. So on step 2, I'm going to say, well, look, angle P is congruent to angle P. And how do I know that? What property lets us say anything is congruent to itself? Well, that, of course, is the reflexive property. All right, angle P is congruent to angle P. Well, now look at these two triangles. They both have two congruent corresponding angles. What does that tell us? That tells us, oh, well, since they have two congruent angles, that tells us that triangle PQT is similar to triangle PRS. And why do we know that? We know that by the angle similarity theorem. Right? Now what we're doing is we're trying to show that the sides are proportional. That, the way I have that written, that is not a proportion. Proportions are two fractions, all right? So look here, I'm trying to show the PQ. So this piece divided by TS, where is, oh man, PQ. PQ kind of goes with PT. Those are kind of the top parts of the green triangles. So I need to show that those two are proportional. And QR, this is bottom section right here, has to match up with that bottom section right there. Right? So what I'm going to do is I need to take an intermediate step here. I need to say, all right, step 4, I'm going to make a fraction. I'm going to make a proportion. I'm going to say PQ over PT. That is proportional to QR. Ooh, I picked a bad color there. QR is congruent to TS. All right, that is my proportion. I'm saying the top left is congruent to the top left divided by the top right is congruent to the bottom left divided by the bottom right. And how do I know that? Why do I know that? I know that because corresponding sides of similar triangles are proportional, right? There's kind of that, new take on CPCTC. We'd use this one for similar triangle sides, all right? But we are now done. What I'm going to do is I'm going to give step 4 a cross multiplication, and we can end up with that proof statement. PQ times TS equals PT times QR. How did I go from step 4 to step 5? All I did was cross multiply. And that one is done. All right. I got one more proof for you, and then we're going to call it a day. Now, I think the directions say use use the picture direct. I just copied the picture down. All right, so same exact picture. I just wanted more room. Okay, what are we given? We are given PT over PS. So where is PT? So PT is this guy right here divided by PS. All right, so we're the top right divided by the entire right side is proportional to, all right, I got QT, and then I have RS. All right, so those are similar sides basically. And now they also tell us that these are parallel. So let's go ahead and just write all of that down in our statements and our reasons T-chart. Step 1. Lots of stuff. PT. I tell you guys not to be lazy, so I won't either. Let's just go ahead and write it all down. QT. For RS, that's the first one. Semicolon, we got a QT. Segment QT. It's going to be parallel to segment RS. All right, that is all given. All right, now, since the lines are parallel, we have to, again, throw back to unit 2. Look for some corresponding angles. Angle 1 and 2 are corresponding. Angle 3 and 4 are also corresponding. Now, we could say both of those, and we could use angle, right? So we don't even need that first part, the proportion. However, they give it to us, so I might as well use it. I'm going to mention on step 2 here, I'm going to say, well, hey, angle 3 is congruent to angle 4, all right? And I know that is true because those are corresponding angles from parallel lines. So I'm just going to put corresponding angles. Corresponding angles of parallel lines are congruent. All right, now on step 3. We can conclude that the triangles are similar. So I'm going to say triangle. Let's go clockwise. P, T, Q is similar. Remember, it's similar, not congruent, but similar. It is similar to triangle P, S, R. All right. And how do I know that? Well, on this particular problem, we are using the side angle side similarity theorem. All right. And hey, that one's done. We don't have to go any further. All right. So look at that. We finished the 3rd page with 1 minute to spare. All right. So I got one more video. So we will see you guys in the next one.